Hello everyone, welcome back to my channel Learning Science, and in this video we are going to continue part 5th of chapter 4, materials, metals and non-metals. So let's proceed. The topic we will be covering in this video is displacement reaction, and it is a very important topic, so you must watch this video till end. Okay, so to understand about this displacement reaction, first you need to get hold of the topic reactivity series. Basically, what is reactivity series is that it is basically the arrangement of what of all these elements in a order in which the reactivity power is from decreasing order. My meaning is to say that you can refer to this diagram and see. And potassium and sodium, as you can see, are the most reactive metal. But as you're going down, as our elements are decreasing in order, that they're becoming least reactive. As you have reached to end, silver and gold are least reactive. So from starting to ending, when we are going, we are seeing that the most reactive metals are slowly losing their reactivity power and are becoming least reactive metals. So this is the reactivity series in which there is an arrangement of the elements in a specific order from the most reactive metals to the least reactive elements. Okay, so this is only some of the elements which are shown here, although there are many, but according to NCERT of class 8, these are only given, so you can only refer to these. So you just need to remember them in case you get confused. Okay, so yeah, so you can know that first is potassium, then sodium, then calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. And you can know that these are the symbols. Symbols, as I've already told you, are a short form for these elements. Okay, so let's proceed. Now displacement reaction definition, it is that when a most reactive metal replaces the least reactive metal from its compound in aqueous solution, it is called displacement reaction. For example, if I say zinc and I say iron, so if we refer to the reactivity series, we find that zinc, it is more reactive than iron because zinc is placed above than iron. That means zinc is the most reactive metal among these two and iron is the least reactive metal among these two. So when I say that, for example, if you have FeSO4 solution, what is this? This is iron sulfate solution, okay? And we add any zinc granule to it. Then what will be the output? There will be displacement reaction. What will be this displacement reaction? That the zinc, it will displace iron from its compound. FeSO4 means that this FeSO4 iron sulfate from that zinc will replace iron and take its place. Okay, it will say that I am more reactive than you, so I will be at your place and you will be at my place. So what is the meaning of saying this is that the output of this will be ZnSO4. Why? Zinc sulfate plus Fe iron. So earlier it was zinc granule, so there was iron sulfate solution which is green in color. Okay, so this was iron sulfate solution, and then we added a zinc granule towards it. The output we obtained was a colorless solution because we obtained zinc sulfate. So zinc sulfate is colorless. Okay, it is colorless plus Fe. Fe means iron. You can find some deposits of iron there. So this will be the output. So similarly, we will take over of other reactions as well. So let's see what we have other reactions with us, and we will try to solve them as well. Okay. So we have first we have copper sulfate plus zinc granule. We know if we refer to this that zinc, it is more reactive than copper. So we find that it is copper sulfate plus zinc granule. That means that copper sulfate. Okay, zinc, it will replace copper from its solution. So we will find zinc sulfate plus copper. Clear? Next is copper sulfate plus iron. Here we find that again iron is more reactive than copper. So again iron will replace copper sulfate from its compound. So instead of copper sulfate, it will be iron sulfate. So it will be FeSO4 plus copper. Okay, because both zinc and iron are more reactive than copper. Now let's see next. Here we have zinc sulfate and copper turnings. Now here we see that copper, it is less reactive than zinc. Now here there will be no change. Why? Because here zinc, copper. Now if here, so for example, any other metal, say potassium was there, then potassium, as it's being very more reactive than zinc, it would have been replaced zinc. But as it is copper here, copper is least active than zinc, so copper will not be able to replace zinc from its zinc sulfate. That's why there will be no change. Okay, next. Now iron sulfate plus copper turnings. Similarly here also we're having copper. Copper is less reactive than iron, so it will not be able to replace iron. So again there will be no change in the solution. Now last one we have zinc sulfate plus iron. So here we again find that iron, it is least active than zinc. So so it will not be able to replace zinc from the solutions. Again there we will find that no change is observed in the beaker. So what we find from all these is that if we replace and we find that zinc, it is more reactive than iron, and iron is more reactive than copper. So this is we find that Zn is more than Fe and it is more than Cu. So these three elements are only given in our NCRT book, that zinc, it is more reactive than iron, and copper is least reactive than iron. So this you have to no. So don't get confused that if zinc can replace copper, then why copper cannot replace zinc? Remember that science is not arbitrary. It is based on facts, on definite truths. It means that only a most reactive metal could replace a less reactive metal. As copper is less reactive metal than zinc, zinc will be able to change it to displace it, but copper will not be able to displace zinc from its compound. I hope this topic is clear. If you have any doubts, please message me. Thank you so much for watching this video. For more such videos, please subscribe to our channel. Thank you. Our part 6 and the last part will be coming soon on the uses of metals and non-metals. So please stay tuned for watching that. Thank you. Keep learning.